going to be page 74. And the date is for March 27th, 2013. A quadratic equation is an equation of the form y equals ax squared plus bx plus c. A, B, and C are values, and then you have your x in the second, you have your x term, and really with the C there's an x to the 0 term, but we don't write that. A cannot be equal to 0. You have to have A a value of 0. This has to be, or is always, a second degree, which means it has an exponent of 2, polynomial function. So it is a function. It does pass the vertical line test that we talked about last week. And another name for quadratic is also a parabola. The graph looks like a parabola. So for these, the easiest way to graph them is really on the graphing calculator. You can put it into your y1 x squared, or you can make a table of values. You can also get the table of values from the graphing calculator. Did a little like that with graph linear equations on the graphing calculator. So I'm going to start with the values -2, -1, 0, 1, and 2. And I have -2 squared. Now you have to be very careful when you put a negative into your scientific calculator. You must square the entire number of -2. If you don't, you'll get an incorrect answer. Because -2 times -2 is a +4. Don't use parentheses calculator. Will most likely just do a -4, which is not correct. So you have -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So when I plot these points, I don't feel like it's enough of a graph to be able to draw 2, -3, and +3. Those are future values of 9 and 9. This is not a V-shape. This is not like absolute values. This is a curve. It is a U-shaped quadratic or a U-shaped parabola. Looks like that. And I label it y equals x squared. Example number 2 is saying y equals x squared minus 2. So really we're taking the example for number 1 and subtracting 2. Switch colors. Have this one stand out a little bit to show that it's different than the first one. And I have same values that I can use, -2, -1, 0, 1, and 2. So I'm going to square the value for x, and then I'm going to take away 2. So really I have 4 minus 2, which is 2. I have 1 minus 2, which is -1. 0 minus 2 is -2. 1 minus 2 again, and 2 squared is 4, 4 minus 2 being 2. So what happens from the green graph in number 1 to the example here in number 2? It looks like we shifted y equals x squared down 2 units. So it's like a slide or a translation, if you remember the vocabulary from transformation, which you have done in the past. I did do that last year. I can also do -3 and +3. If it's a shift down 2, that means I'm going to have values of 7 and 7. So my parabola looks like this, nice U shape. And I'm going to label it y equals x squared minus 2. So it shifted or split the graph down 2. Example number 3 is a graph of y equals negative x squared. So what do you think this negative will do from example number 1 of y equals x squared? Well, let's make a table of values. Negative 2, negative 1, 0, 1, 2. And basically what you're doing is you're taking all of that squared and then making it a negative. So negative 2 squared was 4, but now I have negative x squared. And so really what I'm doing is I'm taking the negative 2 and squaring it, but I have a negative out in front. So that gives me a negative and then the 4. So really it's just a negative 4. So I can take all the values from example number 1 and just make them negative or negate them. Negative 1 squared is 1. So we have a negative out in front. And it's kind of like multiplying by a negative 1. Like negative 1 times x squared. 0 squared is 0, can't make 0 a negative. 1 squared is 1, make it negative. 2 squared is 4, make it negative. You can also add the 3. Negative 3 squared is 9, negate it. 3 squared is 9, and negate it. So when we plot these points, our graph, our quadratic or our parabola, now looks from the original upside down. So really, y equals x squared was reflected over the x-axis for y equals negative x squared. Example number 4. Now they're taking x squared and they're multiplying it by 2. So let's make a table of values for negative 2, negative 1, 0, 1, and 2. So I'm going to square the negative 2, and then I'm going to multiply by 2. So that gives me 2 times positive 4, which is 8. Negative 1 squared is 1, times 2 is 2. 0 squared times anything is still 0. Positive 1 squared is 1 times 2 is 2. And 2 goes along with the 8. So I plot those points, and the parabola looks like this, where it actually was stretched or it stretched y equals x squared by a factor of 2. And I need to go back to number 3, my label on there is distances. And those are graphic quadratics. The best way is to use your graphic calculator when you have access to it, or to just go ahead and make a table of values and figure out where things are at.